Imagine you are driving through an empty city at 3 in the morning. No traffic lights, no other cars, just a silent vehicle moving through the darkness with perfect precision, calculating every turn, every shadow, every possibility. Not because a human told it to, but because it learned from a billion miles of real roads. Now ask yourself, what kind of company builds something like that? Because the answer is not an automaker. It never was. Most people still think of Tesla as the company that makes sleek electric cars with long range and controversial leadership. That framing is not just incomplete. It may be one of the most expensive misunderstandings in the history of technology investing. Because while the world debated whether Tesla would survive the EV price wars, the company was quietly doing something else entirely. It was building infrastructure, not metaphorical infrastructure. Physical, computational, energetic, and autonomous infrastructure at a scale that very few people have stopped to fully absorb. Here is the number that changes everything. In the first quarter of 2024 alone, Tesla spent $1 billion on AI infrastructure. That single quarter. Not on cars, not on paint lines, not on showrooms. On compute, on training systems, on the hardware needed to teach machines how to perceive reality. By 2026, the company has planned total capital expenditure exceeding $20 billion across artificial intelligence, energy storage, and robotics. That is not the spending profile of a car manufacturer. That is the spending profile of a civilization builder. To understand what Tesla is actually constructing, you have to look at the layers. And there are more layers than almost anyone publicly discusses. Start with the data. Tesla currently operates a fleet of millions of vehicles on public roads across the globe, each one constantly collecting visual information, edge cases, rare scenarios, the kind of unpredictable real-world complexity that no simulation can replicate. By the middle of 2025, its robotaxi service in Austin had already accumulated over 700,000 paid rides, with the fleet doubling in scale every single month. No cloud provider on Earth has access to this kind of grounded, physical, real-world training data. Not Amazon, not Google, not Microsoft. They build models that understand language and images. Tesla is building models that understand the physical world at street level, in real time, at scale. Then there is the compute layer. At its peak deployment, Tesla was running approximately 35,000 NVIDIA H100 equivalent processors for AI training, with plans to reach 85,000 by the end of 2024. Alongside that, the company built Dojo, its proprietary supercomputing system designed to reach 13 exaflops of processing power, with an ambition of 100 exaflops by 2025. To put that in human terms, 1 exaflop means 1 quintillion mathematical operations per second. Tesla was aiming to run 100 of those simultaneously, using chips it designed itself, inside data centers it controls. That level of vertical integration in AI compute is extraordinarily rare, even among the technology giants. Now here is where the story takes a complicated turn. In August of 2025, Tesla disbanded its Dojo team. The leader of that effort departed, and approximately 20 engineers left to found a separate startup. The remaining staff were redirected toward data center infrastructure projects. That decision represents either a strategic pivot toward more practical deployment architecture or a significant retreat from one of its most ambitious technological bets. The honest answer is probably somewhere between both interpretations. But what it tells you is that Tesla is not a company operating on a fixed plan. It is a company in active transformation, making difficult bets and sometimes reversing them in real time. What it did not abandon was the broader infrastructure vision. Because Tesla is not just building compute. It is building the power to feed that compute. The Megapack product line, capable of storing 3 megawatt-hours of energy per unit, can be deployed at gigawatt-hour scale in under 3 months, which is 4 times faster than traditional fossil fuel installations. Tesla's virtual power plant connects thousands of residential Powerwalls and commercial Megapacks into a coordinated energy network. This is not a side business. This is a vertically integrated energy layer designed to power an AI ecosystem. Cars collect data. Dojo and data centers train the models. Megapacks power the infrastructure. Optimus robots operate the factories. The supercharger network, now comprising over 8,100 stations and 77,000 connectors globally as of the fourth quarter of 2025, provides the physical nervous system for autonomous mobility. Every piece connects to every other piece. And then there is Optimus, the humanoid robot that runs on the same neural networks as Tesla's self-driving system. 57 kilograms, 1.73 meters tall, with 22 degrees of freedom in its hands alone. Tesla's stated goal is not a research prototype. It is mass production of a general-purpose robotic labor unit. The implications of that, if it succeeds, are nearly impossible to overstate. We are talking about a machine that can see, navigate, manipulate physical objects, and learn from experience, deployed across warehouses, factories, hospitals, and eventually homes. The same intelligence that guides a car through a rainstorm could guide a robot through a surgical suite. That is not science fiction. That is the stated industrial roadmap. So how does Tesla compare to the companies the world already recognizes as AI infrastructure? Look at NVIDIA. Its H100 chip delivers 1,000 TOPS of AI performance. Tesla's current AI4 chip delivers roughly 100 to 150 TOPS. That is a significant gap. NVIDIA uses TSMC's 4-nanometer fabrication process. Tesla's chips were built on Samsung's 7-nanometer node. In raw silicon performance, Tesla is not competing with NVIDIA. It was never trying to. Tesla is building for a different target: inference at the edge, inside vehicles and robots, where the constraints are power consumption, form factor, and real-world latency. The compute war Tesla is fighting is not in the data center. It is in the physical world. Now compare Tesla to Amazon, Google, and Microsoft. Those companies have the cloud, they have the data centers, they have the foundation models. What they do not have is a fleet of millions of physical agents collecting ground truth data from real environments every single day. They do not have an energy storage business, they do not have a robotics line, they do not have a charging network. What they have is software reach. What Tesla has is physical infrastructure reach. And in the coming decade, as AI moves from digital assistants into robots, autonomous vehicles, and smart energy grids, that physical reach may turn out to be the more valuable asset. But here is where intellectual honesty demands a pause. The skepticism around Tesla is not irrational. Analysts at UBS have issued sell recommendations, citing a valuation that at times reached 384 times trailing earnings. Only about one-third of Wall Street analysts currently recommend buying the stock, compared to near-universal enthusiasm for other technology leaders. The autonomy promises have missed timelines repeatedly. The 500 robotaxi target for the end of 2025 was quietly revised to approximately 60 vehicles in November. Nationwide rollout has been pushed to 2026. The Dojo team disbandment is a real setback, not a talking point. And the question of whether true unsupervised autonomous driving can be achieved at scale, and on what timeline, remains genuinely open. No one, including Tesla, has proven it works everywhere. So here is the question worth sitting with. If you were designing civilization-scale infrastructure for the next 50 years, what would it need? It would need to move people and goods autonomously. It would need to generate and store energy at distributed scale. It would need to train intelligence on real-world physical data. It would need robots to operate the factories and logistics networks. It would need a compute layer to run all of it. And it would need the physical charging and energy network to keep it alive. Does any single company on Earth currently have pieces of all of those layers in active development simultaneously? That is not a rhetorical question. Think through the list yourself. The answer is uncomfortable for those who still see Tesla as a car company with ambitions above its station. Here is what most people are still missing. The transition from industrial economy to AI economy is not primarily a software transition. It is a physical infrastructure transition. The companies that control the physical layers, the energy, the mobility, the robotic labor, the real-world data, will have leverage over the digital layers in ways that pure software companies will not. Tesla may be building the wrong supercomputer, missing robotaxi targets, and carrying a valuation that prices in optimism that has not yet materialized. All of that can be true. And it can also be true that the architecture of what Tesla is assembling, vehicles plus energy plus compute plus robotics plus autonomy, represents something that no competitor is close to replicating. The thumbnail you saw before clicking on this video says something is getting much bigger. That is not hype. It is a structural observation. The question is not whether Tesla is a car company or a technology company. That debate is over. The real question is whether Tesla will successfully execute on becoming infrastructure. And whether you, sitting wherever you are right now, will look back on this moment in 10 years and recognize it as the inflection point when the answer became obvious. If that kind of strategic inflection point, the moment when a company transforms from one category into another entirely, is the kind of thing you want to understand before the rest of the world catches up, then make sure you are subscribed. Because the next chapter of this story is already being written, and it is moving faster than almost anyone expects.